Good afternoon. Thank you for the introduction. Yes, I'm Beatriz, and I'm from University of São Paulo in Brazil, but I'm also from TU Delft, as I'm in this moment now as visiting postdoc. In Brazil, my supervisor is Professor Marcelo Zaiat, and in the Netherlands, my supervisor is Jules van Lier. I will start with a small introduction. So, sugarcane Vinasse is the subproduct of the ethanol production. It contains high concentrations of nutrients, especially potassium. Its main destination is the fertigation. However, due to high concentrations of solids, organic matter, sulphate, and also the acidity, the sugarcane Vinasse can decrease the soil quality over time. Several anaerobic reactors configurations have been studied in the last years for treating the sugarcane Vinasse using granular sludge or attached biomass. But because of the characteristics of the Vinasse, the granules of this granular sludge and also the biofilm from the attached biomass can be negatively affected and be a washout of the reactors. Complete biomass rotation can be achieved using anaerobic membrane reactors, providing a better conditions for degradation and a better quality final effluent without solids. There are many types and materials for membranes, but just one type has been studied for sugarcane Vinasse, the hollow fiber type submerged membrane. Polymeric membranes, for example, are cheaper than other materials, and external membranes, as the one in the picture, has some advantage over the submerged membrane, as low folding, easily cleaning and replacing when it's needed, and also they are ideal for viscous fluids. Normally, the anaerobic membrane reactor with external membranes consists in CSTR reactor followed by the membrane module. But there are some studies testing and evaluating other configurations, as for example, USB. In this work, we evaluate the use of anaerobic membrane reactor with external membrane to treat the sugarcane Vinasse. In our setup, we use a USB reactor, with a external ultra-filtration membrane coupled. Let me see if I can. Here. So in this configuration, the effluent from the reactor passes through the tubular membrane when the permeate is pumped out of the reactor, and the concentrator is recirculated back to the reactor. The cross-flow velocity guarantees the mixing inside the reactor and also minimizes the fouling in the membrane. But in addition, we also applied the relaxation process, which consists in stop the permeate pump for a few seconds, so the solids attached in the membrane can go back inside the reactor. In this experiment, we also operate a second USB without membrane as control. And in this table, you can see all the parameters applied in each phase. We tested 6 phases with increasing organic loading rates. The sugarcane Vinasse was collected in one of the largest ethanol power plants in São Paulo, Brazil, and all the analyses were carried out in our lab in University of São Paulo, São Carlos campus. I highlight here the high concentrations of COD, potassium, polyphenols, and sulphate present in this Vinasse that we collected. In this picture here, you can see the difference between the effluent from the USB and the effluent from the anaerobic membrane reactor. With the section of the first phase that was the adaptation and the last phase that was the operating limit, the COD removal efficiency results differ statistically, and the anaerobic membrane reactor had more stability and great COD removal. Polyphenols removal monitoring starts from phase 3. And again, anaerobic membrane reactor had more removal efficiencies. And from phase 5, the USB stopped to remove polyphenols. It's already known that anaerobic membrane reactors are efficient for phenol removal, but those results were kind of surprise for us. We are not expecting that this difference between the reactors. About the sludge, in the first graph, the solids concentration is presented in each phase. The USB had high solid concentrations, while anaerobic membrane reactor had a large decay in the beginning and then a gradual increase during the operation. The particle size distribution analysis shows that the USB maintained the size of its granules during the whole operation, but an anaerobic membrane reactor had its granules completely degranulated, which did not affect its performance. This study is not finalized yet. We are still processing the microbiome community analysis to understand how the reactor's configurations impacted and to also understand the whole of the cake layer of the membrane. Economic analysis will also include the biogas production. What we can conclude from so far is that an anaerobic membrane reactor is suitable for sugarcane Vinasse treatment at an organic loading rate up to 6 grams of COD Lier day. It had great removal of COD and polyphenol compounds, effluent free of solids, and the sludge granulation process did not affect the performance of the reactor. What I can recommend is some improvements in the operation conditions as better control of the pressure level and flow, and also to use backwash procedure instead of the reduction process to avoid the fouling in the membrane. Also to evaluate some intermediate organic loading rates between 6 and 10, and the impact of inorganic compounds on the fouling, the membrane fouling. So thank you for your attention. Feel free to contact me, and if you have any questions.